introduced, I work as an artist, but my work straddles the line between hardware engineering and robotics as well as design. And a lot of the work that I do, it deals with electronics and robotics and also physical fabrication. But I also work with data-driven installations and projections, as well as sculptural installations in public spaces. And then after college, I started a career as a biologist, and for a while I did field research in the desert of Arizona on desert rattlesnakes and migration patterns. And then in 2008, I transitioned from a field of biology into art and hardware. And this snake motion and these mathematical patterns that are reoccurring in biology really manifested themselves in my own work with SNEAL, which engages with this investigation of these reoccurring patterns in nature, and my own deep fascination with creating motion through different algorithms in these kinetic objects. So I want to reference a few just three conceptual frameworks that are driving factors in my own work. And the first concept is called biomimicry, which means mimicking a design based on the form and function of a natural phenomenon. Another concept that my work engages with is the relationship of humans and non-humans and our animals and humans in this very complex natural ecosystem. A third concept that I engage with a lot in my work is that of modularity and how small units could come and fit together to create much more complex assemblies that can perform tasks. And this really engages with the intersection of biology and technology. And this is SNEAL. SNEAL is an ongoing series of biomimetic snake robots, which means that their form and function actually mimics that of a real snake. I began this project in 2011 as an attempt to create an open source robotic platform for offshore data collection. But it also really is an exploration of algorithms that are transformed from software into a physical hardware interface. The original form that SNEAL mimicked was from a project, an open source hardware project that I'm very involved in, and it's called Prote. And Prote was begun in 2010, and it's a shape-shifting sailing robot. It was originally designed to tow an oil-absorbent boom behind it that could absorb oil sustainably off the top of water, and it was developed as a response to the BP oil spill. So it's open source in that we aim to release the designs to allow communities to take a hands-on approach to disaster relief and oil spill. But now Prote acts as a modular platform for carrying all types of different ocean sensors, for looking at things like radioactivity off the coast, plastic trash in the middle of the ocean, and finding oil on the top of the water. But the entire body actually flexes like a snake in order to control the trajectory. A lot of the work that we do is lead hackathons and workshops, and we've done this in places in Europe, in China, Brazil, Morocco, really engaging people to come together to learn how to build DIY and custom fabricated robotic sailboats using tools that are accessible and recycled materials. And we're using Prote as a platform to collect radioactivity off the coast of Fukushima, like here, this was last February, and using it to detect plastic trash in the middle of the ocean, of the Pacific Ocean. So in 2011, I was very interested in building a derivative of Prote, a platform of swimming snake robots that could swim on the water autonomously to collect data and to explore unknown places that humans couldn't access, that eventually have the potential to explore places even like Mars, or for firefighting, search and rescue, or pipeline exploration. So in addition to robotics and hardware, I also design interactive, data-driven public art installations using new and emerging technologies. And a lot of these are collaborative efforts that I do, and more large-scale installations that I've been working on with a studio that I co-founded in Brooklyn. And we're a collective of 5 artists, designers, and software engineers. And we're really interested in using technology as a medium for artistic expression. So this installation is called Landscapes. course of the installation, we save snapshots of the landscape as the architecture morphs over time. We 3D print these objects as sculptural forms. And this completes the circle of translating a physical gesture into virtual data and then back to physical. So each sculpture is one of a kind and represents a specific location and a place in time. So our newest work with Floating Point is a large-scale art commission through Autodesk for a permanent installation on Pier 27 in San Francisco. We're going to install a two-story projection in a crowded passageway where ships pull in and people are disembarking and getting off cruise ships. So we're going to combine real data about Jimmy Herman with an interactive interface using a camera to track people through space. And as more activity is happening, more of these light forms are going to be projection mapped onto these wave-like sculptural formations that are made out of metallic waveforms. In both my work on installations as well as in these robotic platforms, I combine physical and sculptural elements as well as software as a medium to really create and inspire play and explore how different forms of data and algorithms could create different types of motion and communicate in different ways. So thank you very much.